Hello friends, today we will be discussing ladder logic. Before we discuss ladder logic, I want to show you a simple animated introduction. For example, here you have a bridge. A person starts from destination A and has to reach to destination B. Okay, and let's take the case of another person, okay, maybe above this. This gentleman starts from here and has to go all the way to here. Now, so a gentleman starts from here, he has all the way completed from here to here, because there is no gap in between. This line is continuous and it reaches over here. But this gentleman, if he starts, cannot reach over here because here we see there is a gap. So let that gap be represented something like this. But now when gentleman A reaches this place, he pushes some button, right? And this bridge completes. So now this gentleman can slowly walk and reach to destination B, to reach its destination. Now, we use the similar logic for programming of PLCs. They are known as programmable logic control. Here, these rods are known as rungs. These rods are known as rungs. Just adjust the camera. Okay. From here, you might assume there are a certain flow of maybe value or some energy, and this energy starts from here, goes this way, comes again, goes this way, and comes again this. So from this point to this point, it's known as a scan, one scan, right? So in one scan, it goes from the left top to the right bottom. Then we have certain switches. Number one is this, which simply checks if there is an input or not. So this is commonly known as XIO, or examine if open. Now what is if open? Before we go for if open, let's talk about open and close. So this is an open switch, this is a closed switch. Now, this brings us to two more concepts, right? Now this brings us to two more concepts, which is normally open and normally closed. What does normally open and normally closed mean? Normally open means that when we don't switch it on, the switch will remain open or the circuit would not be complete. Normally closed means usually it's closed. When we give it an input, it's going to break open the circuit. Right? So that is the meaning of normally open, normally closed. So when we use this function, examine if open, and I want to check if my point number A, is it on or off. So this function will go to point A and check if it's open or closed. Second is examine if closed. By the way, this can also be known as normally open. When you give an input, the bridge completes. This becomes this when there is an input or one condition present in XIO. And here, this is the normal condition. That's why it's known as examine if closed or normally closed, right? So it remains closed, and when you have an input, this thing removes and the circuit breaks. This turns into this, right? So this is your examine if closed, normally closed function. So then you have the outputs. This is the output function, right? So if you give it an input, it toggles the value of maybe B. Maybe you talk about B. So whatever is the input B, it would toggle its value from 0 to 1 or 1 to 0. And this would happen till the time the input is there. For example, if I have a motor over here, maybe, okay, let's talk about this, and a motor. So if the user presses a button of A, this thing would complete the energy, or for this matter, a gentleman would go, the bridge is complete, he will walk and reach his home. But as soon as the user removes his finger from A or switches off the button A, this would remove automatically, and hence even this would be switched off. So this is kind of a push button. You can compare this with a doorbell. When you press the button, this goes ting tong, but as soon as you leave it, it switches off. So this is the concept of a doorbell. Another important output is the latch, right? And the unlatch. Usually these two are used together. So when you give an input to latch, it would switch on a bulb, irrespective of this input for the second time. For example, you give an input, it would turn it on, and then forget it. Now even if this switches off from here back to this open condition, even then this would remain on. Now if you have to switch it off, you want to bring, like you want to switch the light off, then again you give an input to this gentleman to unlatch, and it would open up this circuit. So this would become closed once you use this function. Hence it's known as unlatch. So once again, we usually have the normally open, latch, normally close, unlatch, and kind of an output, which is a one-time output. Once it has energy, it completes the circuit, else it remains off. So this is ladder logic. Using these switches, we can make multiple applications. And one application that we are going to see today is that of an elevator. So consider a building. It's got 3 floors, ground, first and second. We have an elevator system other one. Now inside the elevator we have a switch system which contains of the button, ground 1 and 2, right? It can also have an open button and a close button. You can have multiple buttons, but that would just make the system complex. We are in an initial state, so we would just be dealing with this. And then on this floor we have an up button. Okay, let's make an arrow. Up and down. That would be to call the elevator from other floors to this particular floor. Second floor we don't require an up button, so we can just remove it. First floor we do require an up button, and the ground floor will only have the up button. So let's name it. Let this be SD. That would be second down. This would be FU and FD. First up, first down, and this would be GU, ground up. Right? Okay. Now, for this particular process, we would require certain sensors. So I'm using a set of sensors that would be one over here, S1, S2 and S3. S1 switches on only when the lift reaches the second floor. Or maybe let me make it vice versa so that it's more clear. Yeah. So when we are in the ground floor, the S1 sensor switches on. When we are on the first floor, the S2 sensor switches on. And when we are on the second floor, the S3 sensor switches on. And there is a common sensor on the lift door that would give the current status of the lift door. I mean, whether it's open or closed. Maybe this we can give the current state. S1. Okay, let's give it an input name of A. Right? So we have an elevator of 3 floors. The elevator has a sensor that checks whether the elevator door is open or closed. So that would be sensor A. Then we have 3 sensors that gives the current position of the lift. That would be S3, S2, S1. S1 gives the position. S1 switches on if and only if the elevator reaches the ground floor. First, if the elevator reaches the second floor. Second, if the elevator reaches the second floor. Sorry, S3 if the elevator reaches the second floor. And then, yeah, these are the set of buttons present in the ground, first and the second floor. They are the up button for the ground floor, up and down for the first floor, and down button for the second floor. And these are the set of buttons G1 to open and close for. These are present inside the lift, right? So the person inside the lift, if he wants to give instruction of which floor he wants to go, he would require this particular control box, control panel maybe. Okay, now let's move to the programming section. Yes. Okay. Okay. Let's start with the most common one. First, let's start with the door condition closed always. So, this would be normally closed, right? So, this particular output, okay, let's it be the C button, right? Okay, and this one, this is the output. So this is some sort of a motor. Okay, sorry. Okay, that's my mistake. I would rewrite it. I think it's out of the frame. Yeah, that's it. Okay, so this is the C, switch C, and this is the door closed. Okay, this is some sort of a motor that is responsible to keep the door closed. Maybe I would write M with a subscript of C, which is responsible to keep the door closed. So when it is energized, the door is closed, and when it is not energized, the door becomes open. So in case of emergency, maybe a power cutoff or something, we don't give energy to this, this particular door would open, right? Okay, in second condition, let's see what would the open button do. Okay, we give an open command to this, right? We press the open button. So that would check S1, S2, S3. Now S1, S2, S3 were the sensors that would determine where the lift was. So if the lift would be in S1, then the current state of S1 would be this, right? And only then the circuit would have been complete. So in this case, we give the input as O. So once the input is open, this would bridge, and if the lift is not moving and it's on a particular floor, only then this would continue and reach some output over here. Let's not discuss it, right? And that's true for either of the floors, whether it's through the ground floor, through the first floor, or through the second floor. And from there, what I want to do is, I want to latch C. From here, I want to latch C, right? And some input output E, right? So from here, I want to latch C and some output A. Now what happens next? Now, So let's just check it. When we latched C, this output, this was a closed switch which now became open, and the door is open, right? But it also powered an output A, which I write over here. So when A started, it triggered a timer of 10 seconds, and after 10 seconds the switch was unlatched. That means after 10 seconds it would come back to its original state, which is of close, and the door would close. So whenever you press the open button, the lift would open, and after 10 seconds the lift would close. So this is the importance of the timer, that we can set it, right? And here it's a dummy output. Why? This output is simply the name of the switch. So switch, when you go here, it toggles the switch. Once the timer starts, automatically after 10 seconds this goes and it unlatches C, and once it unlatches C, it comes back to its closed position, and once it comes back to its closed position, the door closes, right? So here we saw two factors. Number one, the door would remain closed all the time. Second, the door would not open until the lift has reached a particular floor, so that accounts for the safety of the lift, and then the 10-second closing of the lift. And if there is no energy, right, the lift would open, right? And if you want to make it more, we introduced a sensor of, okay, I think the sensor that we introduced, we give it a name A. Let's change the name of the sensor from A to maybe Y, because we have already used A over here. So I think that would create a confusion. So let it be Y. The sensor that determines whether the lift is open or not be Y. Now if you put it over here, sorry, if you put the sensor over here Y, this particular switch would be on only if the door is closed. So when you press the open button, the door, it will check whether the door is open or closed. Okay, it's closed. Then it checks the condition, whether the door is on S1, S2 or S3. If not, it stops. It would not open the door. But if yes, it continues and latches C. That would open the door and also switch on A. A would switch on 10 seconds triggered and again switch back C. So this is how we have functioned the opening and the closing of the door. So if I just give it an output command, it's very well understood that after 10 seconds it switches off, it closes the lift. So this is one very important aspect of the programming that which you really need to know. And mind you, this would just be a push button. I would not require a continuous output over here, because my one input, if I give an input 1, it would simply go and latch C. And after that, once I leave the button, this thing would not matter, and after 10 seconds automatically the door would close. Okay, now let's go to the second part of the programming, which is the user is inside the lift now, and now he wants to go places from ground to first to ground or second, from second to first or ground, right? And for this, I am assuming that there are 3 motor settings. That, for example, the moment I give MG as an output, the motor would take the lift to the ground floor. If I go for the M1, it would take it to the first floor, and if I take M2, it would take the lift to the second floor. So that's an assumption. So these outputs are basically given to a motor. So now the user gives an input to G. which again checks. Okay, this goes and latches maybe an output G. Okay, second step, so maybe GSS. You name an output GSS, it's again a dummy output. You would come to know what does it mean. So a user gives an input G and this goes to the latch GSS. From here it comes over here to the switch. Now this switch is on. Initially it was an NC switch, but now it's on. It would come here and then it would make a check. This would be S1, switch 1. So if it's on the ground floor, what would it do? It would simply go and open the door, right? It would go back to the open function. If it's not, if it's S2, then it would first go and give instruction, or rather it would give instruction to MG, right? So MG's function is to bring the lift to the ground floor. Now depending on the settings of MG, if the motor is programmed that it goes and automatically opens the door, then this would suffice and you would close the rung like this. And if in case the motor is not programmed to open the door, we can make it. So this becomes smack open and we can make the rung like this. So this would go. If the lift is in the first floor, it would first bring it to the ground floor and then open the door, and once again after 10 seconds it closes the door. So this would be GSS, right? And after this, right, after this it unlatches GSS. Now if it doesn't unlatch GSS, this output would remain on and the door would remain open forever. So we need to close back. So unlatch GSS would close this rung. Similarly, we can have this done. We need also for S3. So if the elevator is in S3, so this sensor would close, right? And the energy would flow this way. It would go to MG, bring the people to the ground floor, and then open for 10 seconds, and then unlatch GSS, right? And similar setting can be done for the first floor and the second floor. In that case, this would change to F, first floor, FSS, this would become S2, this would become S1, this would become first floor, and this would become FSS, right? So, and okay, if this was the previous one, the ground floor one, something. So this all would be in parallel to each other. Okay. Right. So these all would be in parallel to each other, and this would only be executed if either of the switch is on. So here we have the G switch, but the user presses only one, G or F, or maybe the second floor. So depending on the input, the rungs would execute. Now for the second floor, this would become S, this would become SS, SSS, S3, S1, S2, SS, and SSS. So when you have all three in parallel, the user enters which floor it wants to go. It just pushes the button once and then the lift works. Now in this second part of the programming, we need to decide if another user has called the lift from outside. Now that in simple terms means the user have either pressed one of these buttons. So I have an option of 1, 2, 3, 4. 4 options, right? Okay, so first we made the open close system, and then we made these three. These three are, which would be the ground first and second, would be for the user who is inside the elevator. For a user who is inside the elevator, so we need to program for the user who is outside the elevator. Now, to make it clear, we are not working on setting up the priority, which usually is the case in the normal elevator, that if the elevator is going towards the maybe 7th floor, and if someone asks the elevator, press the down button on the 5th floor, the elevator would not stop on the 5th floor and take it back. It would first go to the 7th floor, then come back to the 5th floor, take the passengers or the people, and then come back to the ground floor. So we are not dealing with any sort of priorities in this particular example. We assume that the elevators are on the particular floors and people have commanded or called the elevator from outside. So how would that go? Okay, let me just erase some part of the board. So we have already discussed this, and we need not discuss this in detail. Okay, let it be, that should suffice. Now, like I made it very clear, we are calling the lift if and only if it's on a particular floor. If it's moving, we're not calling it. So let's make it very simple, that all the commands would be executed hereafter only if either of the switch is on. So if it's S1, S2 and S3. So either of the sensor, when it's on, only then the particular command from the outside of the lift would be executed. Okay. And then now we have 4 options. That would be 1, 2, 3 and the 4th one, right? So that would be 2nd floor down, 1st floor up and down, and ground floor up, right? So let's make it this way. That would be 2nd floor down, in this particular example, it would make no difference whether we press the up button or the down button on the 2nd floor, because we are not setting up any priority. So it's simply a call button. It could be replaced by a single button, but since I've already mentioned the buttons, let's take it this way. So whether a person presses the up button or the down button, it's simply to call the lift, and we are not setting any priority for the lift. And then here comes the ground up button. That means we are pressing the up button on the ground floor, right? Now, So it checks S1, S2, S3, and there it goes, right? Now, in case the motor is already on the second floor, so it would be this case S3, right? And it would simply go and open the door, right? So we press the SD button. It was there already on the second floor, and it would open the door for 10 seconds, right? It would go back to the first rung where we designed how the elevator opening would work, right? And in case if it's either on the first floor or the ground floor, in that case it would become S1 and S2, right? And coming back, it would switch on the motor, that is bringing it to the second floor, and then it's opening the door for 10 seconds, right? Similarly, here we would have S2. If S2 is there, it would open, and right, it would open, and if it's not there on first floor, so it's obvious that it's in the second or the third floor, right? Sorry, the ground or the second floor, and it would bring it to the first floor, and it would open the door for 10 seconds. And lastly, if it's already on the ground floor, S1 would switch on, it would open the door for 10 seconds, right? And if it's not, it would activate the motor, it would check whether it is on the second or the third floor, and then would take it, if not, it would bring it to the ground floor, and it would open the lift for 10 seconds. Let's make it more clear. Right? And of course the rung closes over here. Okay. So this was the second part of the elevator problem. Now, if we have to combine all the steps of the ladder, step 1 and 2 were for the opening and closing of the door. We made it in the front because we're going to use it again and again, like the open, 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 and we made it automatic closing, so you don't have to close the button when you are in the lift, right? Then in the second phase, the person inside the elevator would give a command, would go into its destination floor, and in the third phase is we are talking about when the elevator is maybe idle on a particular floor and the person have called it for some purpose. Now, this would also mean that there is no priority set in a particular program. I mean, priority makes it clear that if the elevator is going from the first to the third floor, or maybe the 7th floor or the 10th floor, and someone presses the down button on the 3rd floor, the lift doesn't stop nor does it open, because we didn't set any priority of that kind. But if the elevator is on either of the floors, it would definitely take the command, right? So this is a very general example of the ladder logic and of the elevator.